Now, there are four technologies that are coming together to cause this huge change in what it means to be human. And I call these the GRIN technologies for genetics, robotics, information, and nanotechnology. And they're all accelerating on their own curve. The G in the GRIN technologies, genetics, actually, what this is really about is manipulating and understanding cells at their very most basic levels. This is not just genomics, it's also figuring out how to make proteins work that allow you to start having human beings create any substance they want, inside their bodies in order to achieve whatever ends you might want. What you're seeing in the earliest phases, like in the next 2 or 3 years, are pharmaceutical results that should have pretty amazing outcomes. One of them is memory pills. Those should be on the market in 3 to 5 years, and these are pills that dramatically enhance your memory. And all of these enhancements usually follow the same path. They're usually originally aimed at somebody who's really sick. And in the case of memory pills, that would be somebody with Alzheimer's. But then it moves out to the needy well, and then to the merely ambitious. Well, think of what memory pills can do to to suppose you were trying to absorb a new language. Suppose you were trying to get a law degree. Well, these memory drugs have amazing implications. For example, Educational Testing Service, the people who do the SATs, they're already just scratching their head about whether this is going to change their business entirely. They make the case that whatever it is that these SATs test is something that's basic and innate in human nature. And well, suppose with these memory drugs, suppose that you can in effect buy an extra 200 or 400 points on your kids' SAT tests with these well, think of what parents do now to get their kids into the most elite colleges. You can just imagine. I mean, everybody who's involved in creating these memory pills are convinced that this is the biggest thing since Viagra. That this is going to be one of the great commercial products of all times, and there's never reason to think that they're right. Other products that are in the near-term pipeline include vaccines that cure addictions like smoking. Imagine what a smoking vaccine, what that would cost. And of course, it's all working on the brain. It's all shutting off parts of the brain or turning it on at will with this chemistry. DARPA is very interested in conquering sleep. There's already an enhancement drug on the market called modafinil, also known as Provigil. And what it does, it's not a stimulant. It's not like speed. It doesn't get you all wired and hyped. It just shuts off the human trigger to sleep. You just don't feel like going to sleep. And the only major side effect that anyone's noticed is that it increases your concentration somewhat. So when I wrote about this, I spent 40 hours awake under the influence.
You tried it?
I tried it. It's a prescription drug. You can get it from your internist. The magic words is to say, I have to fly to Tokyo and give a presentation, and I need to be sharp. Do you have anything for that? And the answer is yes. As a matter of fact, we do. And the answer, well, anyway, so it's available on the market right now, and this is still the primitive stuff. And when I handed in my copy, my editor said, "Gee, this reads a lot cleaner than your stories usually do." So, enhancement or what? And that's just the first generation. The DARPA notes, for example, that whales and dolphins don't sleep the way we do. They can't. They're mammals. If they slept, they drown. So they've learned to turn on and turn off different parts of their brain to sleep, a portion of the brain at the time. And DARPA says, wouldn't that be great if we could have that happen to our troops? And then what about hunger? A special forces troop goes through about 12,000 calories a day. It's like, Phelps's metabolism. Well, 12,000 calories, you can't eat that much. I mean, it's like 3 meals ready to eat and 48 power bars. you can't even carry that much. And so they're trying to figure out how to solve this. And they thought, well, suppose we just don't feed them at all for a week. Suppose they can just go without food. The way you do that is that we carry lots of energy around in our body all the time, and it's stored in our fat. And the trouble is that the mechanism to get at the fat energy is locked up because you normally can't access it unless you're starving. So they're saying, well, suppose we identified this mechanism and allowed it to trigger at will. And I'm writing this all down, and all of a sudden I realize that they're talking about triggering your ability to burn your fat at will. And I say, me, give some to me. I mean, I've been working out for how long, and to what effect, and when you say something like that, they kind of, at DARPA, they kind of smile this little smile, and they say, the civilian implications of this technology have not eluded us. Dieting is like a $40 billion a year industry in this country, and if this ever works, it's over. That ends it. I was talking to a friend of mine who's a science and technology analyst who's very, very skeptical about all of these human enhancement technologies, and I'm finally telling her about this fat thing, and she says, "It does what?" And I tell her, "You can burn your fat at will." She says, "Okay, so I fry in hell for this. Sign me up." There's the R, the robotics, and what that is a melding of the made and the born. It's talking about getting machines and the living to work interchangeably, smart machines that do our bidding. Now, again, this has been around for a while. Vice President Cheney is a cyborg, as you well know. He's got all sorts of gear in there around his heart that has, I mean, he's a real human-machine combination there. But again, you haven't seen anything yet. This is just the start. In 2002, there was a flying robot called a Predator, which is a robot that is an unmanned air vehicle that can stay up in the air for a very long time and just do whatever you want it to do. And in 2002, it came up for the first time behind an SUV in Yemen. And it turned out this SUV was full of people who were identified as Al-Qaeda leaders. And this robot had Hellfire missiles under its wings, and it proceeded to fire one and leave this large smoking crater where the SUV had been. So this raises the question, was this the world's first robot to murder human beings? And now you can get into a debate about this. This Predator was not completely autonomous. There was a human in the loop, and it made the decision to pull the trigger and all that jazz. So the question is, can you really consider this a robot? And reasonable people differ. But this could be seen as to be a conversation that could be a little bit overly fine if you were one of the guys in the SUV, as to whether or not this is a true robot. The point is that you do have intelligent machines that are doing our bidding to the point now where all the powers of our comic book superheroes from the 30s and 40s, every single one of them either right now exists or is in development. For example, we just had a movie called Iron Man that came out, in which you put on a suit and you end up with incredible strength. That exists. It's called an exoskeleton. And at the University of California at Berkeley, where they've developed one version of this, I jitterbugged in this suit. And what it's designed to do is to allow you to lift 180 pounds as if it was 4 pounds, and to walk all day with a 200-pound pack as if it were nothing. When I was there, I said, think of it as like a wearable robot suit. You kind of like put it on like a suit, and it senses the motions of your legs and your arms and your muscles, and it simply amplifies it so that you can lift things that would otherwise be impossible. And so I said, well, if this amplifies my legs, does this mean that I can leap over tall buildings with a single bound? And they said, sure. Landing. Now that's a problem.
So consciousness is a complete mystery to neuroscience. Why we subjectively experience anything, like the feeling of pain or the redness of red, whenever there are certain kinds of activation in the brain, is a problem we don't even know how to think about yet. Current large-scale brain initiatives tell us a lot about the brain, but seem so far unable to make progress on this matter. It is as if knowledge of the brain does not include knowledge of the mind. So even if we knew every cell in every thinkable brain process, we would still not suddenly discover consciousness as this physical object inside the brain. Neuroscience today typically offers you one of two kinds of explanations for almost all kinds of questions. Some seem to prefer to try and explain mental phenomena based on physical localization in the brain, while others prefer connectionist models inspired by the way computers work. But neither seem really able to bridge this kind of mind-brain gap. Surprisingly, none of those two models are very good at understanding brain injury either. It's still a paradox to connectionist models why localization of injury seems so important. Yet it's a paradox to localizationist models how functions can be lost and recovered without a regrowth of the same lost tissue. Now, of course, any kind of theory of the brain able to handle and support an understanding of complex matters such as subjective experience or neurorehabilitation will be of great value to many different disciplines and may revolutionize artificial intelligence and robotics, and possibly also ethics, as mentioned a moment ago. So, if our current models of the brain find consciousness to be this big mystery, and if they can't really guide clinical neurorehabilitation either, then we probably need completely new models. And those should probably not be extensions of the traditional ones, but rather try to do something completely new. So let us begin with some simple observations. Introspectively, it appears that everything that we experience is information that we have access to. It is somehow available for flexible actions. You might not act on it, but it is available to you. Just look for yourself. Everything that you experience is something that you can act on or report or talk about. Now, the brain, however, doesn't seem to perceive the world directly as it is, but seems to come up with the best reason or cause for why it is in its own current state. I believe that this kind of process makes information available to us, and that the outcome of that, say action outcome, in return modifies this analysis of causation through backpropagations. And I believe this kind of fundamental reciprocal relationship is fundamental in order to understand the mind. I would say that consciousness depends on it. I wouldn't say that consciousness is identical to it or reducible to it. That would be different kinds of thinking. So this kind of reciprocal model or function can be described at several different levels of description. And my model begins with the surface manifestation level, if you want, or the level of the mind rather than from neural components, simply because it's a possibility that the mind can be realized in a number of different ways. That is, different strategies that the brain is able to employ. And those strategies should be thought of as a kind of orchestration of very simple functions, of elementary functions in the brain that are truly localized. They are orchestrated in global or large-scale networks, perhaps, as strategies in order to realize this kind of manifestation level. And every time we succeed in doing something or even perceive something, these networks of elementary functions will be strengthened. Now, should an injury occur to an elementary function, a different kind of strategy, which may be markedly different, which may be as effective or less effective, seem able to take over this realization. And this can only be possible due to a constant reorganization at the level of elementary functions. So please note that this idea involves a very important change of perspectives. The upper level here seems to reorganize the lower level of description. That is, cognition alters brain architecture. You might say that you need to understand the mind in order to be able to understand the brain. In this way, I would argue that the brain constantly optimizes its own functions given resource limitations, not by analyzing loads of data, but by backpropagations from action and cognition. So in this way, a function can be the same and different before and after a brain injury, dependent on the level of description. And in my model, the upper level or the surface level seems to have two aspects. a functional one and a subjectively conscious one, and neither can be reduced to the other, as said before. And if that is right, then neuroscience can never completely explain consciousness. However, the relation between the two can be understood and described. So it is probably soon time that we discuss what we can do and what we should not do once we have this knowledge. And therefore, my question to you is also how we might apply insights into consciousness for various clinical and practical purposes.
Welcome to Critical Thought TV. I'm your host, Stuart Dambrot. Today we have Ben Goertzel, a cosmist and singularitarian. Also, among his many other affiliations, the CEO of both Novamente and BioMind, as well as the Chief Science Officer at Idea Holdings, as well as the Chairman of the Artificial General Intelligence Society and the OpenCog Foundation. Let's start off with what you're doing in robotics and virtual worlds.
One of the projects I'm working on now, which is based in Hong Kong, in a lab at Hong Kong Polytechnic University, is focused on using OpenCog, our proto-AGI system, to control animated characters in a virtual world. The reason we chose this isn't just because video games are fun. It's because a character in a video game world provides a sort of microcosm of everything that human intelligence has to do.
Quite right.
You have perception, you have action, you have language, you have socialization, you have to move around and find things. Pretty much everything that happens in the real world happens there, but in a simpler form.
And there's also then, of course, I mean, I shouldn't say of course, but I saw because I'm asking, but there's also the opportunity to have our agency in terms of intention and goal setting within that space, rather than just being like in a first-person shooter game, reactive based on the appearance of an enemy or a ghoul or whatever it might be. That in fact there could be a part of the whole missed goal-seeking and planning aspect to the AGI entity within the virtual world, if I'm right about that.
Yeah, absolutely. The AI in the virtual world has a collection of different goals which govern much of its behavior. Some of these are basic. Say if the AI is controlling a simulated robot, it wants to find batteries which give it electricity to keep going. It wants to feel safe and no one's going to steal its batteries. Some of the goals are more generic. It wants social interaction. It wants novelty. It wants to learn new things.
This is important, right?
Yeah.
Yeah.
So in order to pursue these goals, it goes around and figures out what to do in the world. So for example, if the AI character is walking down low on the ground and there's somewhere high up, if there's a battery up there, it may have a motivation to get up there. But also, if it's just never seen what's up there, its goal of experiencing novelty makes it think, well, maybe there's something up there I don't know about. What is it? I really want to know that. Then it tries to figure out how to get up there, and it can figure out how to cobble together objects that it can climb on to get up to the top and see that thing.
Now, that example speaks to me very strongly about more human-like or human-analogous curiosity and intelligence and motivation and relations between the perceptual systems and the motor systems, because you have to see where you're going but plan how to get there in terms of actionable physicality and all the rest of that. That's very interesting to me. The other, in terms of finding batteries, I could imagine that would be something that could be very well defined in a certain way. And it brings to mind this research I read about where there were real-world robots that had to find an energy source. And they spontaneously, on their own, learned, and they communicated using light patterns of LEDs. And they learned how to send a false message to competitive robots so that they would go in the wrong direction of the supposed energy source so that the deceptive robots, in fact, had primary access to it. I think this is great. I think this is exactly what human beings would do in that situation. And to me, that was a profound result because they were not told or programmed in any way to do such a thing.
Mm-hmm.
I think this is great.
Yeah, I think that the virtual world has a lot to recommend it in terms of early stage prototyping of advanced AGI systems. It also has the advantage that if you were to roll out a game or a virtual world with AGI characters in it, potentially you could get millions of human players to collaborate basically in teaching your AI by playing the game.
Right. And they wouldn't even have to know that they were teaching. In fact, it's better if they don't.
They may pay you for the privilege of teaching your AI.
Right, by playing the game, they're teaching the AI.
Exactly.
That's great. That's terrific.
So I think that's important. On the other hand, I do suspect there's an ingredient that you can only get from actual physical robots. In other words, the video game worlds and the virtual worlds have a very limited richness of perceptual data and of motor action affordances compared to what you get in this everyday world we live in. It's not really a fundamental in-principle point because I think you could build, in principle, a simulation world that was incredibly richly detailed. But in practice, that's not what we have now. The video game worlds, I mean, they don't have fabrics, they don't have hair, they don't have complex fluid dynamics, there's no peanut butter, there's no clay. If you think about what little kids like to play with, an awful lot of it, it's not just blocks, right? An awful lot of what little kids like to do is learning from all these different materials and substances and their interactions.
Right, and the malleability of clay, and the ability to not just have tactile feedback, but the sensation of a surface and all of that's critical. It also reminds me, I wanted to ask you about this because it just occurred to me. George Lakoff and the whole world of metaphor. He does hold that in his parlance, the conceptual metaphor is something that is based on a primary metaphor, and a primary metaphor is something that is embodied knowledge that results from interaction with the environment in a prelingual state. So that being the case, it just occurred to me that what you're talking about, once especially embodied in the real world, could lead at some point to the emergence of metaphorical language capability in an AGI, and I was wondering what you thought about that proposition.
Absolutely. An awful lot of our language is indirectly and implicitly based on our physical embodiment. We use metaphors like, he pointed out that what he's pointing may be some completely abstract mathematical thing, but we still say he pointed out. And like, well, he was on the verge of doing this.
On the verge, right. The road ahead.
Yeah.
Referring to the future. And people actually lean forward.
He backpedaled on his statement.
Yeah, exactly. Right.
I mean, there's an endless number of spatial, temporal, physical metaphors that are embedded in our language as well as in our abstract thinking.
Very good, yeah, very good.
I wouldn't go so far as to say that you could never make a human-level AGI without a robot body to interact in the world. I think you could do it other ways, but to me, that's the most straightforward way. But there is a dilemma there as an AGI developer. On the one hand, dealing with robots is a real pain right now. They never quite work right. The robot technology we have today is quite crude and primitive.
And they fall over and break, as you once told me as well. That's an issue.
On the other hand, using the robotic embodiment, in principle, gives you so much more in terms of integration of perception, action, cognition, language, and in terms of, as you said, understanding linguistic structure in terms of your embodied experience. And
in terms of the affordances you mentioned as well after Gibsonian ecological psychology, that those are evolutionarily determined. They arise naturally because of the interaction over time, but time can be manipulated, and temporality can be manipulated in a virtual world, so it can be sped up, but it's based even in that virtual or real world on interaction, real world interaction.
But fortunately, robotics technology is advancing pretty fast. I've been talking a lot with two outstanding roboticists, David Hanson, who's building the Hanson RoboKind, which is a commercial humanoid robot about this tall with a very emotionally expressive robot face. And then Mark Tilden, who's based in Hong Kong, who is the mastermind of WowWee, which made the Robo Sapien robot, which doesn't break when it falls down the stairs. And interestingly, Hanson's robot is also manufactured by Jetta, based in Hong Kong. So we've got a sort of robo AI community
That's great.
developing there with Western AI and robotics design guys basically working with the Chinese robot manufacturers across the border in China, because China is really the only place now that knows how to make complex robots at scale and low cost.
Oh, that's very interesting. Yeah, yeah.
So I think that in the next few years, as robotics technology gets better and better, it's going to become more and more viable for AI and AGI researchers to work with robots, and I think that's very positive.
Especially if we want to reach DARPA's goal of having autonomous AGI robotic armies by 2050.
Oh, there you go.
All right.
Yeah, one interesting example of robot technology that I've just seen recently, there are robot fingertips.
Quite right. That's
manufactured by a company called SynTouch.
Yes, they even have fingerprints
Yeah.
that
So
allow them to
they're
have
pressure
minute
sensitive.
sensations. Yeah.
They're pressure sensitive, temperature sensitive, and heat sensitive.
And they're able to curl with many more degrees of freedom around
movement
round
sensitive.
objects.
So these fingertips can distinguish things based on touch as well as based on.
And many times better than a human can in terms of
In
differentiating
some cases,
what the surface of that object
if you look
is
at a
like.
problem like picking up this cup, I mean, doing that by vision only is going to be pretty annoying, right? I would rather close my eyes and pick up the cup with touch only than do it by vision only.
Right.
But we really do it by a combination, and we do many things using that combination. And the synergy between vision and touch, I think, is cognitively important in terms of how we understand the world, because vision is sort of at a distance. It's almost a third-person view of things.
Right.
Touch is very intimate. I mean, that whatever you touch becomes almost like a part of you, very briefly.
And audition is somewhere in the middle. We know we don't have to. We can hear from the sound that it's on the table surface.
Yeah.
All right, but we're holding it, so it's linked to that sense modality, but we don't have to use vision.
Audition lets us sense movement in a very direct way, which is a unique contribution of audition. If you want to hear whether someone's coming toward you or away from you, I mean, you can hear that and you can sense it quite readily, whereas telling it by vision is a bit dodgier sometimes and less precise. So each of the senses contributes a different thing conceptually. We integrate them all that helps us understand the world and understand ourselves conceptually. As robotics technology advances, we're getting further and further toward the point where AGI systems can build a similar conceptual understanding to what people have. And I think this understanding that you can build an AGI mind through its robot embodiment can be helpful for many AI tasks that wouldn't seem to rely on robotics. I've been doing a lot of work applying AI to analyzing genetics data. We're looking at genetics data from long-lived flies that live 4 or 5 times as long as normal people, produced by selective breeding over 30 years. We're applying AI technology to genetic data from long-lived people, looking at healthy people age 80 over versus matched controls who are age 80 or over but not healthy, trying to understand the genetic underpinnings of longevity and age-associated disease. Now, on the face of it, this would seem to have nothing at all to do with little robots walking around. It seems like you're just crunching genetics data. But here's the thing. Most of the information you need to interpret the genetics data is in research papers. Now, how can the AI understand all these research papers? Well, the AI can understand these research papers if it could read. right back to the language understanding problem, and you're back to the fact that the metaphors and expressions used in research papers are largely drawn from embodied experience.
Ah, quite right.
To take another point, reading papers and analyzing data isn't all you need to do to understand longevity. You need to design new experiments. Right now, humans design experiments. AI is a tool that we help to analyze the data generated by the experiments.
An AGI could design experiments.
An AGI could design experiments, but the way that we design experiments, even if they're quite abstract experiments using sequencers and gene expression technology, the way we design biology experiments is heavily conditioned by what we do manipulating physical objects in the everyday world. Any preschool teacher will tell you that the kids are learning to be little scientists. They're learning to do experiments as they play with stuff. As you cook, you're learning to do experiments. The intuition that scientists have for how to design experiments partly comes from their abstract study of the scientific method, and partly comes from tinkering, from their everyday life experience fiddling with stuff. Robotic embodiment will not only help AIs learn to be better service robots or manufacturing robots, it will give AIs an intuition for how to fiddle around, tinker, and experiment with things, which will then help the AI to do better genetics experiments, design better biomedical experiments in general.
Thank you so much. That's great stuff. Thank you very much.
I'd like you to start by imagining that this humble device was harnessing quantum mechanics to monitor your state of health and then to securely communicate with your doctor, also harnessing quantum physics, and that your doctor would then prescribe you a new drug that has been designed on a quantum simulator, and that his diagnosis was informed by a quantum computer. Now that future and a whole lot more is potentially soon possible. So as bizarre as quantum physics is, it turns out to be the basis of some incredibly disruptive quantum technologies. And what I'd really like to emphasize today is that these technologies are emerging from the research lab. So at the University of Bristol, we're working with a large range of organizations to develop these quantum technologies that will have profound impacts on all of our lives, societies, and economies. These will occur in four main areas. The first is in security. So probably all of you have wondered about how secure your mobile phone is when you log into your bank or you buy something online with it. Well, working with our colleagues at Nokia, we've developed a secure communication system that would allow your handheld device to communicate with your bank teller machine. And the way that works is that you and your bank encode your information in single particles of light, single photons, and the laws of physics demand that if anyone extracts some information from that transition, that will disturb those single photons, and you and your bank can detect that. The second area is in sensors, which are becoming ubiquitous in transport, environmental monitoring, security, and healthcare. And it turns out that if you want those sensors to be as precise as they possibly can to make their measurements most precisely, then you need to harness these bizarre properties of quantum physics. Already we have been able to measure the concentration of a blood protein using this bizarre state of entangled photons, and that's a really key step to making this into a practical technology. And so the third area is in designing new materials, new clean energy devices, and new pharmaceuticals. So probably many of you are aware that it takes of order $1 billion in 10 years to bring just a single new drug to market. And a big part of the reason for that is that it's impossible on a normal supercomputer to be able to simulate the molecules at the heart of that. So working with our colleagues at Harvard, we've developed a new, very efficient quantum algorithm for doing such a simulation, and we've been able to simulate the helium hydride molecule to within chemical precision. So that's the precision that you need if you're able to do something useful with that knowledge. And the final area is in quantum computers that offer exponentially greater power for some important tasks. For example, quantum machine learning would use artificial intelligence type approaches to address what would otherwise be impossibly large data sets. And this has applications across all sorts of things, ranging from email filters through to online shopping, face recognition, training driverless cars, and the list goes on. We've developed a technique at the University of Bristol for using photons in waveguides on a chip. And the important point here is that we're guiding those photons around in silicon waveguides on the nanometer scale. And this is precisely the same architecture that the conventional computer chip industry is using. So they have ambitions to replace all of the copper wires that we currently have in computer chips with these sort of photonic wires. Now, apparently Seymour Cray, when he was told that Apple had bought a Cray supercomputer to design the next Apple, said, "That's funny, I'm using an Apple to design the next Cray." And perhaps you would all like to think about how you might use a quantum computer to design the next Apple, to design some new medicine, etc. Now, the really good news here is that you can start trying your hand at this already. So just last week, we've made one of these devices available online on the quantum cloud, and if you log into that email address there, you can start programming a small-scale photonic quantum processor. And I encourage you to have a look at doing that, and there's some tutorials along with it that should explain how you can go about doing that. So finally, I'd like to acknowledge the European Research Council who've made all of this possible, and leave you with a message that quantum technologies are arriving now. And my question for you is, what would you like to use these technologies for? I really want to hear what your problems are, because that's my main reason for being at this forum here, is to find out, amongst all the applications that I've just touched on, and there are more, where do you see your business being affected? How would you like to apply these things? Thank you.
Welcome to Critical Thought TV. I'm your host, Stuart Dambrot. Today we have the inimitable Ben Goertzel with us. Ben is a self-described cosmist and singularitarian. He's also the CEO of Novamente and BioMind, and as well as the Chief Science Officer of Idea Holdings. Among his other affiliations, he's the chairman of the Artificial General Intelligence Society, as well as the OpenCog Foundation. Welcome, and thank you so much for coming.
Thanks for inviting me.
It's really my pleasure, more than I could say. I thought perhaps that since the focus is going to be largely on artificial general intelligence, we'd best start with some terms, concepts in AGI, and perhaps even more importantly, what differentiates AI and AGI. I say that because even amongst practitioners, there's debate. There are some AI practitioners that say AGI is an unnecessary concept and acronym. So I'd like you to address that, because I disagree with that position.
When the field of AI was founded in the late 1950s, it had a pretty ambitious scope. The idea they had then was to create computer programs and robots that could think as well as people, that could do everything that people can and more. Since that time, the field of AI has broadened a lot. One of the things that has been discovered since those early days is that you can write computer programs doing a lot of pretty intelligent things in a way that has nothing to do with human intelligence, and in a way that's very, very narrowly specialized. So for example, Deep Blue beat Garry Kasparov, the world chess champion at chess. But Deep Blue doesn't think about chess like people do. It thinks about it in a very narrow, focused way. Deep Blue can only play chess. It can't play any other game. It can't generalize from one domain to another. Since the field of AI has spread out so much to encompass all these very narrowly focused intelligent programs, doing things like playing games, driving cars, predicting the stock market, managing the supply chain, controlling military robots, it's become useful to specifically distinguish that part of AI that's really concerned with human level intelligence or with general intelligence, with thinking like people do it, which is not just tied to one application area, but spans pretty much everything using the same methods. Humans can take something we learned in one domain and transfer it to another domain. We can do this kind of lateral, creative, analogical thinking, which lets us cope with problems that didn't exist when we were born.
More than that, it's also the case that we're driven to do that, which is another thing altogether. We're driven to extrapolate. We're driven to generalize. We're driven to find patterns between distal areas that then lead to something new and creative, like you were saying. So how can you draw, I would say one, then I would ask if that is one differentiation between a true AGI and just, say, an expert system or some of the other examples you were mentioning.
I think there are 2 points in what you just said. One is that human beings are agents. They're not just problem-solving tools. So a human being controls a body in a world. It has certain goals which can shift as the human being develops over time. Some of them are built-in goals, wired in by evolution, getting sex, getting food, staying alive. Some of them are goals that we pick up culturally or create ourselves during our lives. But we are agents with certain goals, controlling a body in an environment, and that sets us apart from most of the AI programs out there that are pretty much tools used by some other agent to do something.
Ah, I see.
The other point that you raised has to do with what are the goals of human agents or AGI agents. You could make an agent with a very specific goal, like kill the enemy, win the chess game, find the cure for cancer. On the other hand, you can make an agent with a more general goal, like learn new things, improve yourself, expand your scope of functionality, create new things. When you create an agent with open-ended goals like that, then you're creating something that can develop and go in all sorts of new directions over time. Human beings are agents with pretty open-ended goals alongside the more basic biological goals.
Right.
AGI systems, if they're really going to flourish up to the human level of intelligence and beyond, I think they need to be agents and they need to have open-ended goal systems. This is both an amazing opportunity and it's a challenge and it's a risk, because once you've created an AI with an open-ended goal system, that AI can develop in all sorts of different directions. It becomes harder to predict and constrain what it's going to do.
Right. Which leads to the ongoing debate between should we not create these open-ended AGIs if, in fact, they're not their behavior and their thought processes and their goal setting is not predetermined, and we don't know what it's going to be. Therefore, we don't know if they're going to look at us as something that is perhaps irrelevant. That whole argument that is put forth by quite a number of players in the space. On the other hand, it could also make the case that because we don't know what level of benefits to human beings can come about because of an emergent AGI. So I'd like to ask you where you fall on this line and how you see it in terms of the line of is it something that because it's could be unpredictable is something that needs to be avoided rather than embraced?
Whether or not to create advanced AGI is a very uninteresting question because it's just going to happen. This is just the next stage in the development of complexity and intelligence and freedom in this corner of the universe. You know, we had the prebiotic soup, we had early stage one-celled life forms, we have multi-celled life forms, we have plants, we have animals, now we have humans that have developed culture and machines, and what's going to happen next is advanced engineered artificial general intelligences. The only thing that is going to stop it, potentially, the only thing that could stop it potentially would be if we blow ourselves up or annihilate ourselves with some other advanced technology. As a thought experiment, imagine what happens if President Obama decides, let's stop all AI development. Well, that doesn't stop the rest of the world, right? That just means that advanced AIs are going to be created in China or somewhere instead.
Analogous to the Bush administration cutting funding for federal investigations into stem cells, for example. It went on elsewhere.
What was interesting there is that it went on in New Jersey and California and various states that funded stem cell research with state funding. So if you look at the history of publications in stem cell research, there wasn't even a period where the U.S. fell behind because the U.S. central government didn't even manage to impose that mandate.
Right, because it was federal funding only.
If you even take the next step, you can say, what if the U.S. government decided to outlaw AGI research, but allow narrow AI? So the government could say, well, we'll allow AI to kind of help us drive our car and do web search and help us blow up people, but help us predict the stock market, play games, but we're not going to allow an AI to become an AGI, become truly thoughtful and intelligent. Right. The problem becomes, where do you draw the line? Let's say you have a home service robot. Everyone would buy a home service robot if it were available. If you could pay a couple $1,000 and get Rosie the robot to go around and clean up your house and walk your dog, everyone's going to do it. But then everyone wants their home service robot to be smarter and smarter.
Until you get Millennium Man.
Yeah, sure.
Right.
And if you're using narrow AI, statistical prediction methods to predict the stock market, who wouldn't want a slightly more intelligent thing with a little more general understanding to help them make more money on their portfolio, right?
Right, quite right, yeah.
There is a difference between narrow AI and AGI. However, the borderline, it's not easy to pin down from a legal point of view, because the AI research community, can't even agree on which pieces of narrow AI are going to be critical components of AGI. Which pieces of AGI could be generalized into narrow AI? Sorry. Which pieces of narrow AI could be generalized into AGI? So how could the government ever put a dividing line?
Moreover, you would think that, I mean, I may be wrong about this, so I'm asking, but a robust AGI system would have, just like we have low-level non-neocortical but encephalized functionality, you could see that an AGI perhaps would have narrow AGI as, say, embodied, if you will, embodied processes that would be narrowly focused.
I think so.
Yeah.
In my own approach to AGI, which is the open source OpenCog architecture, we combine a number of different components together in a cognitive architecture. The overall architecture is modeled on human thought, but the individual components that we integrate together, each of these has some functionality on its own as a narrow AI system. For example, we have a component that we call MOSES, which is an acronym for something complicated, Meta-Optimizing Semantic Evolutionary Search. So this component I'm using now to analyze genetics data to try to help figure out why people live a long time. I'm using that component in a stock market analysis project. That component is being used to help a video game character figure out how to build things with blocks. But that same component plays a critical role in OpenCog's attempt to become an artificial general intelligence.
Because it can apply whatever the algorithms Moses is using, I'm guessing at this, to itself. So it's a reflexive application of its own programmatical state in some ways, which is what we do when we reflect on our own thoughts. In a sense, we're applying how we use thinking to evaluate our own thinking process and look at our own thoughts using thoughts. So that's very interesting.
So the point would be, if the U.S. were to outlaw AGI development, but they allowed development only of these components, then someone else can take our components and make an AGI from them, right?
All right. Thank you so much. Welcome to Critical Thought TV. I'm your host, Stuart Dambrot. We're here with Ben Goertzel, a self-proclaimed cosmist and singularitarian, the CEO of Novamenti and BioMind, and the Chief Science Officer of Idea Holdings, as well as the Chairman of the Artificial General Intelligence Society and the OpenCog Foundation. Welcome.
Thanks for having me.
It is so my pleasure to have you here. It's great. Okay. What happens after the singularity? I mean, this is an open question. We're not even going to get into the fact or the debate about whether it's going to happen or not, or if Ray is accurate enough, or any of that. Let's assume, if you will, that it is coming. The timeline is roughly accurate, 20 to 30 years, something to that effect. But even if that's not the case, what happens in a post-singularity environment, in your view?
When Werner Vinge first proposed the concept of the technological singularity, the way he put it was, after this point, we just don't know what's going to happen, because...
Rainbow's End in the 80s, I think. I believe it was in that science fiction novel.
Rainbow's End was a more recent novel.
Yeah. Oh.
Is it Marooned in Real Time, perhaps?
Oh, perhaps that was it. Yeah, perhaps that was it, yeah.
Anyway, Werner Vinge's vision of the singularity was a point after which we can have no idea what's going to happen. Ray Kurzweil has put forward a sort of kinder, gentler view. He seems to see the singularity more as kind of like life as it is now, but without any shortages of energy or health, without a limited lifespan, with all the goodies we want. I tend more toward the Vingian side of singularitarianism. I tend to think a singularity is likely to happen, and it's going to be a radical discontinuity. It's hard for us to predict what comes afterwards. But as well as a singularitarian, I consider myself a cosmist. What this means is that I don't identify. What this means is that I don't identify myself purely as a human being living in human society. I am that, and humanity is important to me. But I also envision myself as a sort of citizen of the universe, as a certain stage in the development of intelligence and life, going from long before humans and long into the future. I think human beings are important, but I think the whole intelligence of the universe is important, including radically transhuman things that may go far beyond anything we can understand now.
It reminds me a little bit of Randall Kuhn's universal Darwinism, and looking very far down the road when he talks about substrate independence, but that could be not what you're going after at all, but it just reminded me of it.
Universal Darwinism is one perspective, looking at the evolution of the universe as a sort of survival of the fittest, on and on, far beyond human beings. I'm not sure whether that's the best metaphor. Biological evolution may not be the best way to think about what happens after you have superhuman AIs that can reconfigure matter according to their will. Evolution is more about competing organisms struggling for resources in a sense, whereas once you have superhuman AGIs ruling the roost, the opportunity for them to exchange information between their own minds with each other may mean it's more like one big AGI mind rather than a bunch of independent entities competing with each other. In the case that it's more like one big cosmist, universal mind network, the whole way of thinking of Darwinian evolution may not be relevant.
Oh, I see. I understand.
One of the more interesting speculations about post-singularity intelligence was put forward by my friend John Smart. He wrote a paper called the transcension hypothesis. And this is kind of an interesting hypothesis. You have to follow the reasoning. We can already see in the recent evolution of technology that computer chips are getting smaller and smaller. Technology is being miniaturized, right? And nanotechnology is often seen as the ultimate extension of that. Actually, nanotech is for wimps. Femtotechnology is going to be much more interesting. That's building things out of elementary particles. Take neutrons, protons, gluons, intermediate vector bosons, build stuff besides boring old atoms, build new forms of degenerate matter out of these particles. Why would you want to do that? Well, the same reason that we have miniaturized electronics so far. Special relativity, Einstein's theory of special relativity, says information can't go faster than the speed of light. So if you want to be really, really smart, you want to get smaller and smaller so your components can communicate more rapidly among each other. But what's the ultimate extension of that? First of all, it's femtotechnology, building stuff out of particles. Secondly, it's an increasing density of your computing elements. You want to pack more and more particles closer and closer together in larger and larger bulk to get a very dense, massive computing core that can communicate among itself incredibly fast. That's how you want to go if you want to make something maximally intelligent, which is probably what a post-singularity mind is going to want to do. But what happens when you get something really, really big and really dense? It becomes a black hole.
Yes, it does.
This is one possibility. A post-singularity intelligence makes itself such a powerful computer, it becomes a black hole, shuts itself off from the rest of us. That's a very interesting potential solution to the Fermi paradox. Physicist Enrico Fermi's question, where are all the aliens out there? Why aren't they sending us radio messages? Well, the answer may be, when an alien civilization reaches the level of technology that would enable it to send radio messages, within a couple hundred years after that, it reaches a singularity. It compresses itself and becomes a black hole. Goodbye. On the other hand, there's the possibility that different black holes may be connected by quantum wormholes.
Or Einstein-Rosen bridges.
Exactly. You may have various kinds of tunneling between black holes. In that case, what we could have in the universe is a bunch of black holes containing superhuman intelligences from species that have passed their singularities, connecting by quantum tunneling, Einstein messaging.
It would be quantum tunneling, you know, which since entanglement and quantum tunneling are features of the quantum realm.
Sure.
And these black hole AGIs would be also quasi-particles in a sense,
it's quantum gravity tunneling.
Yes, yes.
It's wormholes through space-time. There's also quantum theory involved. It's an interesting speculation. What it would mean is that there's this other aspect to the universe of compressed superintelligences living inside black holes, communicating through some kind of gravitational / quantum wormhole thingies, and then all of us idiots who haven't reached this singularity yet are out here in the rest of the universe.
And we can presume that even a couple of months ago there were three separate research papers showing how it's possible using reversible algorithms to extend the life of coherence, so that the ability to avoid entanglement death. That's now. That's right now.
If you're talking about femtotech, if you're talking about advanced AGIs that have figured out how to dispense with atoms and assemble elementary particles into new kinds of intelligent quark gluon plasma or whatnot, I would imagine that quantum coherence could be maintained over large, massive, complex objects in that kind of scenario, potentially even having the same degenerate matter tunneling through curved space-time, maintaining its quantum resonance between different black holes. This is all complete wild-ass speculation.
But it makes sense to me. I mean, it's Stargate AGI-1. Right?
Yeah, what it indicates is that there could be a lot of things beyond Terminator robots stomping around on the Earth, or any kind of anthropomorphic AGI that we're thinking of. Now, we have to bear in mind that physics has revised its fundamental theory of the universe every 50 or 100 years or so. Right. So it may well be that by the time we get to the singularity, we won't have these same ideas about black holes and tunnels through curved space-time and so forth. Anyway, it may be something even far wilder and stranger that we can't even imagine. But I do think it's important not to constrain ourselves to an anthropomorphic view of post-singularity AGI. How could we ever understand the thoughts of some quark gluon plasma with 88 quintillion times more the processing power of humanity distributed among multiple black holes through these tunnels? I mean,
that are space-time irrelevant, that are completely decoupled from space-time.
It may be able to reshape space-time locally as part of its thought process.
And if you, especially if you subscribe rather to the particle physics view of forces in gravity, but the Einsteinian geodesic as a conformational feature of space-time in the vicinity of mass, then in fact you would expect that. You would expect it to, and since it's a conscious entity as well, that would be, I think, not a necessary but a highly probable outcome.
Well, go a little further out there even. Now, Kurt Gödel, the famous mathematician, he also dabbled in physics, and he showed there's a solution to Einstein's space-time equations that would allow you to travel backwards in time. If space-time were curved the way that Kurt Gödel said, you could fly this direction. Eventually you would come back where you started, but earlier. Now, imagine you had an AGI that could reshape local space-time inside its personal black hole to enable this kind of curvature. Then it could be going around in causal time loops of backward time travel.
And you know what else there could be? There could be then, you know, the hypothetical entity of negative energy, right? Which could be used in principle if it exists, and if it could be enough could be collected, if you will, in a certain constrained space. It could be used to expand and contract space-time at will. So it would be like in Dune, traveling without moving.
There you go. There's a lot of possibilities out there. My hope is that if there are human beings who post-singularity want to remain in the classic legacy human form with all this meat and hair and all these cognitive limitations, my hope is that these humans will be permitted to do so, just as we now have ants and bacteria swarming around the Earth. But for those humans who choose not to do that, for those humans who choose to upload their minds into computers, for those humans who choose to fuse with the machines, which are becoming more and more palpable possibilities as technology progresses. Actually, I just edited a special issue of a journal on mind uploading. It's the first journal issue on mind uploading with contributions by all these serious scientists. The Journal of Machine Consciousness.
Randall has his paper
that's right. So for those who embrace these concepts, want to upload their minds and fuse with AGIs, and progressively increase their intelligence far beyond the human level, we really can't see what the limit is now. The point of all these physics speculations is just the sky is not even the limit. It's, as Vinja thought, it's going to be far beyond what we can comprehend.
Thank you so very much.
Was this the world's first robot to murder human beings? And now you can get into a debate about this. This predator was not completely autonomous. There was a human in the loop, and it made the decision to pull the trigger and all that jazz. So the question is, can you really consider this a robot? And reasonable people differ. But this could be seen as to be a conversation that could be a little bit overly fine if you were one of the guys in the SUV, as to whether or not this is a true robot. The point is that you do have intelligent machines that are doing our bidding, to the point now where all the powers of our comic book superheroes from the 30s and 40s, every single one of them either right now exists or is in development. For example, we just had a movie called Iron Man that came out, in which you put on a suit and you end up with incredible strength. That exists. That's not, it's called an exoskeleton. And at the University of California at Berkeley, where they've developed one version of this, I jitterbugged in this suit. And what it's designed to do is to allow you to lift 180 pounds as if it was 4 pounds, and to walk all day with a 200-pound pack as if it were nothing. When I was there, I said, think of it as like a wearable robot suit. You kind of like put it on like a suit, and it senses the motions of your legs and your arms and your muscles, and it simply amplifies it so that you can lift things that you would otherwise be impossible. And so I said, well, if this amplifies my legs, does this mean that I can leap over tall buildings with a single bound? And they said, sure. Landing, now that's a problem. Now, there are 4 technologies that are coming together to cause this huge change in what it means to be human. And I call these the GRIN technologies for genetics, robotics, information, and nanotechnology. And they're all accelerating on their own curve. The G in the GRIN technologies, genetics, actually, what this is really about is manipulating and understanding cells at their very most basic levels. This is not just genomics, it's also figuring out how to make proteins work that allow you to start having human beings create any substance they want, inside their bodies in order to achieve whatever ends you might want. What you're seeing in the earliest phases, like in the next 2 or 3 years, are pharmaceutical results that should have pretty amazing outcomes. One of them is memory pills. Those should be on the market in 3 to 5 years, and these are pills that dramatically enhance your memory. And all of these enhancements usually follow the same path. They're usually originally aimed at somebody who's really sick. And in the case of memory pills, that would be somebody with Alzheimer's. But then it moves out to the needy well, and then to the merely ambitious. Well, think of what memory pills can do to to suppose you were trying to absorb a new language. Suppose you were trying to get a law degree. Well, these memory drugs have amazing implications. For example, educational testing service, the people who do the SATs, they're already just wondering, scratching their head about how whether this is going to change their business entirely. They make the case that whatever it is that these SATs test is something that's basic and innate in human nature. And well, suppose with these memory drugs, suppose that you can in effect buy an extra 200 or 400 points on your kids' SAT tests with these memory. Well, think of what parents do now to get their kids into the most elite colleges. You can just imagine. I mean, everybody who's involved in creating these memory pills are convinced that this is the biggest thing since Viagra. That this is going to be one of the great commercial products of all times, and there's never reason to think that they're right. Other products that are in the near-term pipeline include vaccines that cure addictions like smoking. Imagine what a smoking vaccine, what that would cost. And of course, it's all working on the brain. It's all shutting off parts of the brain or turning it on at will with this chemistry. DARPA is very interested in conquering sleep. There's already an enhancement drug on the market called modafinil, also known as Provigil. And what it does, it's not a stimulant. It's not like speed. It doesn't get you all wired and hyped. It just shuts off the human trigger to sleep. You just don't feel like going to sleep. And the only major side effect that anyone's noticed is that it increases your concentration somewhat. So when I wrote about this, I spent 40 hours awake under the influence.
You tried it?
I tried it. It's a prescription drug. You can get it from your internist. The magic words is to say, I have to fly to Tokyo and give a presentation, and I need to be sharp. Do you have anything for that? And the answer is yes. As a matter of fact, we do. And the answer, well, anyway, so it's available on the market right now, and this is still the primitive stuff. And when I handed in my copy, my editor said, "Gee, this reads a lot cleaner than your stories usually do." So, enhancement or what? And that's just the first generation. The DARPA notes, for example, that whales and dolphins don't sleep the way we do. They can't. They're mammals. If they slept, they drown. So they've learned to turn on and turn off different parts of their brain to sleep, a portion of the brain at the time. And DARPA says, wouldn't that be great if we could have that happen to our troops? And then what about hunger? A special forces troop goes through about 12,000 calories a day. It's like, Phelps's metabolism. Well, 12,000 calories, you can't eat that much. I mean, it's like 3 meals ready to eat and 48 power bars. You can't even carry that much. And so they're trying to figure out how to solve this, and they thought, well, suppose we just don't feed them at all for a week. Suppose they can just go without food. The way you do that is that we carry lots of energy around in our body all the time, and it's stored in our fat. And the trouble is that the mechanism to get at the fat energy is locked up because you normally can't access it unless you're starving. So they're saying, well, suppose we identified this mechanism and allowed it to trigger at will. And I'm writing this all down, and all of a sudden I realize that they're talking about triggering your ability to burn your fat at will. And I say, me, give some to me. I mean, I've been working out for how long, and to what effect, and when you say something like that, they kind of, at DARPA, they kind of smile this little smile and they say, the civilian implications of this technology have not eluded us. Dieting is like a $40 billion a year industry in this country, and if this ever works, it's over. That ends it. I was talking to a friend of mine who's a science and technology analyst who's very, very skeptical about all of these human enhancement technologies. And I'm finally telling her about this fat thing, and she says, it does what? And I tell her, you can burn your fat at will. She says, okay, so I fry in hell for this. Sign me up. There's the R, the robotics. And what that is a melding of the made and the born. It's talking about getting machines and the living to work interchangeably, smart machines that do our bidding. Now, again, this has been around for a while. Vice President Cheney is a cyborg, as you well know. He's got all sorts of gear in there around his heart that has, I mean, he's a real human-machine combination there. But again, this you haven't seen anything yet. This is just the start. In 2002, there was a flying robot called a Predator, which is a robot that is an unmanned air vehicle that can stay up in the air for a very long time and just do whatever you want it to do. And in 2002, it came up for the first time behind an SUV in Yemen. And it turned out this SUV was full of people who were identified as Al-Qaeda leaders. And this robot had Hellfire missiles under its wings, and it proceeded to fire one and leave this large smoking crater where the SUV had been. So this raises the question,